What makes the weather change? ES2 lesson 6, and we're actually going to be doing 6.1 today. And it's a learning set 2 because this is the second half of the book. And if you look at the top of page 51, it's titled, Does the Storm Model Fit Data from a Storm? And that's the whole idea of lesson 6. And specifically for 6.1, it's can we identify patterns in data? And that's a really big thing in science. You've got to be able to look at patterns, analyze patterns, figure out what's going to go on. And basically, that's how meteorologists are able to predict the weather. They look at patterns, what's happened in the past, what's happening now, and then they're able to predict reasonably well what's going to happen in 2 hours and 3 hours and 5 hours, and tomorrow, the next day. And meteorologists can reasonably predict the weather out 3, 4, 5 days and be fairly accurate. So the expectation for you is to complete this activity today. So let's take a look at this. Now this may look similar to something we've looked at before because we analyzed weather maps back in activity or lesson 5. So where do you see clouds in this picture, in this weather map? And how do you know? So think to yourself, where do you see it? And you're probably looking already right here where all this gray is, but what is this color? Well, the color is actually precipitation. So when it asks you, where is it raining? How do you know? Well, the areas of green, yellow, and orange all indicate areas of precipitation. So just because it's cloudy doesn't necessarily mean it's raining. So if you're looking at this with a satellite from above and you see that it's cloudy, it doesn't necessarily mean that it's raining out. So these different colors here represent different amounts of precipitation. And so it is raining over Chicago and Kansas City and over into the St. Louis area. Now, are there any symbols on here that you have not seen in previous activities? And for most of you, you're going to say no, because what it's going to do is point out these lines, dashed lines right here. But we actually saw dashed lines like this on a prior map. However, those dashed lines on that map just circled areas of precipitation or snow. These actually have a different meaning. And those dashed lines, they can be brown, they can be black, they're called troughs. And they are actually elongated areas of low pressure at the surface or aloft. They actually cause similar weather as a low pressure system. I think the other day I thought they were similar to a warm front, but I was wrong. I misspoke. They're actually similar to a low, and here you see a low here. So it's just saying that this low system is elongated. It's a little bit larger than possibly normal. And so it creates another front where warmer, less dense air rises and creates precipitation. So it's similar to a warm front because you have the warm front right here, but you have a cold front here. And typically with low, that's where you're going to have your warmer weather. But it's meteorologists say it's very similar to a low pressure, not necessarily a warm front. Now this can actually make the storm stronger and more intense. So here's a couple of key facts. Rain forms where areas of different pressure meet. So this is typically going to be a cold front or a warm front, possibly a stationary front, and even an occluded front. Now rain forms just in front of where the two pressure areas meet because that is where the less dense, lower pressure air is rising. And as it rises, remember, it cools off. The moisture, the humidity in the air will condense, it'll form clouds, and then pretty soon you're going to have precipitation going on if there's enough lift. Now, here are the procedures for today. Now, they're a little odd in the sense that they're not quite in order. So, for example, procedure number 1 says, begin by answering the questions about the surface area map. So, look at the map on page 51. Now, if you flip over to page 52 at the very bottom, where are the storms on the map? So we already kind of talked about that. But you notice at the top of page 52, there's a data table. So they're not necessarily in order. I don't know why they didn't put the questions above the data table. So when I first looked at this, I said, okay, where are the questions? I don't see the questions. They're at the bottom of page 52. So begin by answering the question on the bottom of page 52. Where are the storms on the map? And the second one, are high pressures and low pressure areas shown on the map? How can you tell? So answer those two questions. Once you get done answering those two questions, if you look at page 53, 54, and 55, that's what you're going to be finishing up today in class. So with your group, use the data on the pages after the map to complete the chart, which can be found on page 52. Be sure to record any changes that occur or patterns that you observe in a data table. And procedure number 3, you will draw vertical lines on each graph to show the time periods for the chart. Those lines will help you find the patterns and compare them. So we're actually going to draw some of those lines in together just to make sure that you know where the lines go. And basically what we're going to do is we're going to be drawing in lines before the storm. So we'll have a line, a vertical line or a horizontal line, depending on what type of data you're looking at, where the storm, before the storm hit, during the storm, and then after the storm. So we're basically drawing in 2 lines, and then you're going to be dividing your data into 3 different parts: before the storm, during the storm, and after the storm. And the reason why we're doing it is if you look at your data table, it says weather conditions at Midway Airport, and that's where this data was taken. You're going to have a box for temperature, air pressure, humidity, and precipitation. So the first column that you see right here, what you're going to do is you're going to write in a description. What do you notice before the storm about the temperature? What do you notice about the air pressure? What do you notice about the humidity? What do you notice about the precipitation? And do a good job with this. A lot of times when I'm not right there looking over your shoulder, how much are you writing? Are you just putting 1 word? Are you putting 2 words? Are you writing a really good description? This tells me a lot about you as a student. Are you looking to just to get done? Are you looking to do things in a hurry? Or are you really trying to do well? I know especially some of you in second hour, you like to rush through stuff. You like to put as little as possible. So take your time. Do a good job on this. Fill these charts out completely. And that doesn't mean write in a size 30 font. So, oh, Mr. Ratun, I can only get 1 word in here because there's not enough space. Well, then write smaller. So when you look at this middle column here, this will be during the storm. So what did you notice about the temperature during the storm? How did it change? What patterns are you seeing? If you go back to the procedures, it says with your group, use the data on the pages after the map to complete the chart. Be sure to record any changes that occur or patterns that you observe. So what changes do you see? What happened from before to during? Do you notice any patterns between the temperature, the air pressure, the humidity, the precipitation? Do you know any patterns before, during, and after? And then finally, you're going to do the after. So this will be the big thing I'm going to check for. And when we go through this, I'm going to check to make sure you have all this done, because this will only take you about 15 minutes to do. So you should easily be able to finish up today. So let's talk about drawing in those lines. So if you look here, here's your first piece of data. Let me grab a pen. So right up here it says, prior to 1:51 a.m., so if you draw a line right here, sorry, that was just a little crooked. That's a really bad line. So this was before the storm. 1:51 to 5:51. So if I draw another line right here, this was during the storm. And then obviously this was after the storm. So when you go back to your chart on page 52, unless you're Cassie, you have a slightly different page for this. You're going to have to fill in, what do you notice about the temperature? What's happening prior to the storm? Okay, what happened shortly after the storm came and then during this time here? And then what happened after the storm? So I'm looking for specific answers. And the blue team, the yellow team, the purple team, the orange team, the red team, you guys should all have the yellow team, if I didn't say you before, you guys should all have very similar observations. So that is temperature. So how about air pressure data? Again, I'm just going to go here. I'm going to draw a line about 1:51 and then 5:51. So here's your before, here's your during, here's your after. So go ahead and fill out your data table for this. What did you notice before? What's happening to the air pressure? What happened shortly after 1:51 and during the storm, and what happened afterwards? Does this make sense based on what we know about barometric pressure, about what we talked about? All right, here's your humidity. So again, I'm just going to go to 1:51. Here it is. Here's 5:51. So you have your before, you have your during, you have your after. What do you notice? What patterns are you seeing? Are you seeing a pattern between here, here, and here? Are you seeing a pattern between the temperature? Are you seeing a pattern between the air pressure and humidity? What kind of patterns are you seeing? And if we go to the last one right here, so I can't draw this line vertically, but yet here's your 151. I'm going to draw it horizontally here. Here's your 551. So what do you notice about the precipitation before the storm, during the storm, and after the storm? So go ahead and fill out your chart. Again, you should be able to describe what happened. You know, if we were to do this one together, I would say, okay, I noticed that at 8:51 there was no rain, and there was no rain for several hours, but there was no rain actually until 1:51. But between 1:51 and 2:51 it started to rain, and it really poured a lot at the beginning. And then it tapered down. So from 2:51 to 3:51, it rained still half of what it rained between 1:51 and 2:51, but then it kept dropping until you get to 5:51 where we had virtually no rain. And then it did rain a little bit after that, approximately the same amount between 4:51 and 5:51 as 5:51 and 6:51. So you can get very detailed versus what happened? No rain. What happened? Rain. What happened? Little to no rain. So you can see, just using a couple words is not enough to describe what happened. You know, if you said lots of rain, well, lots of rain at the beginning. But then towards the middle, there was still quite a bit of rain, but then it started to taper off. Are you talking about that? So I'm going to be coming around checking your observations. Make sure you have good observations as a team. Now, once you get done with this, if you look on page 55, there's some more work for you to do. So look at page 55. It says, did any of the patterns in the data surprise you, given your model? Pick one variable that you found surprising or interesting and explain what you thought and why. So here are my directions for you, because I know what some of you were thinking. It says pick one variable. Now it says, did any of the patterns in the data surprise you? Some of you are just going to say, no, nothing surprised me. Well, if nothing surprised you, pretend that something surprised you. And pick one variable that you found surprising. Again, pick one and explain what you thought and why. So I don't want you to leave this blank and just say, oh, nothing, I found nothing surprising. That'll tell me, one, you didn't watch this video, and two, you didn't follow my directions. So again, make sure you pick one, and this should be a good sized paragraph. Don't just say, oh, precipitation, I found it surprising that it rained. No, talk about it. Explain what you thought. So this should be a good sized paragraph for page 55. So make sure you get done with this today, so that way the next time we meet, we're going to go through the answer key and see how you did. Thanks, and make sure you ask questions during class if you have any. Okay, bye.